So this is a little bit of an extra video on probability. If you didn't watch the first video of this series where I talk about the basics of probability, you should watch that one. So especially if you're trying to pass the additional focus area on probability outside of grade math, this is very useful. Basically, how you determine the number of possible outcomes when you have sets of different events all combined together. Like say, for example, you're trying to figure out the outcomes of rolling a 6-sided die and of flipping a coin. Well, there's a lot of ways to do that. One of them is let's list all the possible variations that could happen. Or you can also determine the number of possible outcomes of each event and then multiply them together. And that should be the total number of outcomes that you can get. So let's try to list them first, right? So I could get heads and then roll a 1, or heads and then roll 2, heads and roll a 3, heads and roll a 4, heads and roll a 5, heads and roll a 6. But I could do all of the same thing, rolling tails then. That seems like the total is 12. So I got that total by simply listing the total possible events that could take place and then counting them. Or I could follow some logic. There are 2 possible outcomes in coin flips, heads or tails, and 6 possible outcomes in a standard die. If you multiply those, 2 times 6, you get 12 as the possibilities. Either way is doable. Another way you can also do it is to do what is called a tree diagram, which shows the possible representations of what could happen. Like here, for example, head could be with any of these numbers, and tail could be with any of these numbers. And so this is a good tree diagram to represent all the possibilities. And if you count them, you will get 12 total at the end. So following the same example of the color die, that's how you do a tree diagram. The other way of doing it, if you have only 2 sets of possible events, like for example, I'm using a die and I'm using a coin, is to make a table where you put one event in the columns and the other event type in the rows. So I put the coins here in the rows, heads versus tails, and I put the die in the columns, 1, 2, 3, 4, 5, 6. And then by combining each of the columns with each of the headers of the rows, you can create all the possible events. It's similar to listing, but that way it's a good way to make sure you've listed them all, right? And that is creating a table. Now, how would you then figure out a probability of a compound event, which is something happening with the first set of events and something happening with the second type of set of events, and what is the chance of both of them happening together? Like for example, like I say, if I'm trying to figure out the chances of getting heads and rolling an even number, right? So again, one way of doing that is to list all the events using the list or the table or the tree diagram and count all the occurrences that satisfy my outcome out of the total. So if you go back to your list and you see I'm looking for heads and even, right? So that works, and that works. And there's 3 out of my 12. And so the probability would be 1/4 or 0.25 or 25%. Now, there was another way I could have done it. I could have just gone to the diagram and look at that 1, 2, 3 heads plus evens out of the 12, or the same thing in the table, H2, H4, and H6 out of the 12. All of these are ways to count how many satisfy my thing out of the total. So if you start from the list, the tree, or the tables, it will be a good place to figure that out. There is an alternative way to do it, though. What you can do is figure out the probability of the first event, and then the probability of the second event, and then multiply those probabilities. And that also works. So we figured out it was 25%, right? So let's see how that works. The chance of getting heads is half because you can get heads or tails. The chance of getting an even number in a die is 3 out of 6 because there's 2, there's 4, and there's 6 out of the 6 sides of the die. So the chance of the first event is half, and the chance of the second event is also half because 3, 6 is also half. And so the chance of both events happening together, heads with evens, would be half times half, which is 1/4, 0.25, 25%. So it works too. So you can do it that way. Either way you do it, this is something that you can easily do to figure out probabilities of compound events. So this is useful for if you're trying to pass the additional power focus area, and if you just want to learn a little bit more about statistics. I hope you found this helpful. Don't do anything that would make your mama proud.